the sigma notation in partial sums. So the sigma notation in partial sum. After completing this lesson, you are expected to use the sigma notation for sums. And in addition to that, you identify the properties of summation notation. And after that, you will try to apply the properties of summation notation to evaluate sums. Okay, so let's continue the lesson. The Greek letter sigma, often called this letter, the Greek letter sigma often called this summation symbol. And we use this summation notation to write sums in a very compact form. So this summation notation symbol is used to write the general term of the sequence. You may have a general term of the sequence, and using that and using this symbol together, we'll try to write the sum in a very short or a compact form. So let's see how to use this summation symbol. This summation symbol together with the general term of this sequence. Assume the general term of sequence is AK, and this summation symbol. Using these two together, you write the sum at like this. So the summation of AK, K starts from 1 up to N, is written in this form. So it is A1 plus A2 up to AN. The meaning of this one means add the terms of this sequence starting from 1 up to N. So this lengthy summation is written in very short form like this. This is a summation of AK. K starts from 1 up to N. So in this summation notation, we call this K an index. K is index. K is index. And this one we call this the lower limit, and N is the upper limit. So for the sequence, if we have this sequence, K start from 1 up to infinity. If we have this sequence, the n's partial sum. The n's partial sum, that means the sum of the first n terms. That means, so the n's partial sum is denoted by the symbol Sn, and it's given by Sn is equal to, it is A1 plus A2 up to AN. That means Sn add the sum of the first n terms of that sequence. So starting from first one, A1 plus A2 up to AN. So when you add this, or when you write this in a very compact or in short form, you can use the summation symbol. So the summation of AK, K start from 1 up to N, is it? So simply, the summation or the sigma notation is this. It's a merely shorthand notation of a sum, or it writes the sum in a very compact form. That's it is simply use. So let's proceed to the next part. Now let's see the properties of sigma notation. Now the first property here is the summation of C times AKK starts from 1 up to N is given by C times the summation of AKK starts from 1 up to N, where C is a constant. Now let's try to prove this property. Now to prove this property, let's start from this one, proof. The summation of C times AK, K starts from 1 up to N, this is equal to, simply this means it is add the terms of the sequence starting from the first term up to nth term. So put 1 first in place of K, you get this one, C times A1 plus next term C times A2 plus the next term. It goes on like this. Up to C times the nth term. the nth term. So this is it. So from this, you can factor C outside of this sum. So C times this equal to A1 plus A2 plus up to AN. This is it. So from this you can see that this is the sum of k start from 1 up to n. So this is equal to C times the summation of k starts from 1 up to n. So this completes the proof. So simply you can prove the property. Now let's continue to the second property. Second property, the summation of AK plus BK, where K starts from 1 up to n, is equal to summation of AK, K starts from 1 up to n, plus the summation of BK, K starts from 1 up to n. So this means summation property, so summation notation can be distributed over addition. This means the summation of AK plus BK is equal to this one. So let's prove this property. Proof. The summation of AK plus BK, K starts from 1 up to n, this equal to. So this means add the terms of this sequence starting from 1 up to nth term. So this equal to A1 plus B1 plus the next term. When you put 2 here, you get this one. It is A2 plus B2 plus it goes on up to the nth term. The nth term is AN plus BN. So this is equal to, you can separate A1 plus A2 plus up to AN and B1 plus B2 up to BN. So I can write this in this form. It is A1 plus A2 plus up to AN, the first part, A's part, and plus the B's part, this is B1 plus B2 plus up to BN. Therefore, this means it is the summation of AK, K starts from 1 up to n, plus this one is the summation of BK, K starts from 1 up to n. So this completes the proof. So simply you can see that summation notation is distributive over addition. So this is it. Now let's proceed to the third property. The third property is similar to the second one, summation of AK minus BK. This is equal to the summation of AK minus summation of BK, where K starts from 1 up to n. So I hope you can prove this easily by yourself, similar to the second one. So I'll leave this property for you. Simply, summation notation is this distributive over subtraction. Now let's continue to the fourth property. The fourth property here says the summation of AK, K starts from 1 up to n, is given by the summation of AK, K starts from 1 up to m, plus the summation of AK, K starts from m plus 1 up to n, where this m is between 1 and n. Let's see the proof of this property. Proof. The summation of AK, K starts from 1 up to n, this is equal to, this can be written as A1 plus A2 plus up to AM. I can write like this, and then plus next to m's term is this m plus 1's term. So this is am plus 1's term plus the next term am plus 2's term plus it goes on up to the n's term. So I can write this in this form. So from this you can see that this one is the summation of a k where k starts from 1 up to m. I can write this in this form. This is equal to, that is the summation of a k starts from 1 up to m, it's m's term. So plus this part is it is also the summation of ak where k starts from m plus 1's term and that's the n's term. So I can write this in this form. It is the summation of ak where k starts from m plus 1's term. K starts from m plus 1's term to n's term. So this completes the proof. Now let's proceed to the other property of summation notation. The next property is the summation of c where k starts from 1 up to n given by nc. Let's see this one. By the way, the n general term of this sequence is c. It's a constant. The general term of this sequence is c. So the general term is c. This means the first term is c, second term is c, all terms are c. So now let's try to add these terms starting from the first term. So let's proceed to the proof. The summation of c where k starts from 1 up to n, this is equal to the first term is c, second c. So the first term is c, it's constant. The general term of the sequence is constant. So the first term is c plus second term c plus third term c plus n's term is also c. So how many c's do we have here? We have n c's. Therefore, this will be n times c. Therefore, the summation of c where k starts from 1 up to n is simply nc, where c is constant. Now let's see another property of the summation notation. Okay, so the sixth property is simply it is the summation of c where k starts from m's term up to n's term. In this case, simply we have to count how many c's do we have. So starting from m and up to n means the number of terms is simply, it is the difference of the two plus 1. For example, let me show you this through example. For example, if we have this, look, the summation of, let's take summation of c where k starts from 2 up to 5. If you take this means add this term is starting from the second term up to fifth term. The first term is excluded. So in this case, simply this means it is the first, if you write from starting from first term, c plus how many c's? We have 1, 2, 3, 4, 5 c's if you start from the first term. But in this case, k starts from 1. The first term is not included. So we have 4 terms. So simply it is 4c in this case. Therefore, easily you can count the number of terms by just simply subtracting the two. 5 minus 2 plus 1. It is 5 minus 2 plus 1 times c. This is 5 minus 3 plus 1. It is 4c. So the summation of c where k starts from 2 up to 5 is 4c. So generally the summation of c where k start from m up to n is given by this formula. Simply take the difference of the index, add 1 and multiply by c. So this is a proof. Now let's continue to the other part. Okay, let's see examples. Let's try this one. Let's start from this. Evaluate each of the following. Let's start from this one, the summation of 2n, where n starts from 1 up to 8. Let's see this one together first. Solution for the first one, the summation of 2n, where n start from 1 up to 8, this is given as is equals to, you can take out, using the property of summation, you can take out the constant outside the summation. So take outside 2, so 2 times the summation of n, where n start from 1 up to 8. So this is equal to 2 times, put 1 here, just add the terms starting from 1. So when you put 1, this term becomes 1, 2, plus up to 8. So when you add this, you get this result. The sum of these numbers is 36 times 2, so the sum will be this 72. This is the answer. Now let's proceed to the second example, B. Okay, let's see this one. Let me give you almost 40 seconds to try this one for you. So try this and we'll do it together. Constant can be factored out from the summation. So it is 5 times the summation of k, where k starts from 3 up to 10, minus this one itself summation of 4, where k starts from 3 up to 10. Let's continue. So this equal to it is 5 times. Here you have to focus, it's k start from 3. So you put 3 and up to 10. So 3 plus the next term is 4. You put 4 here, 4 plus up to 10. You have this minus the summation of this constant number. If you remember, the summation of c, or constant number, to find the number of terms, simply take the difference of these indexes, 10 minus 3, and you add 1. 10 minus 3 is the 7 plus 1, 8. We have 8 fourths here. So simply it is 10 minus 3 plus 1 times 4. So the result will be 5 times, if you add these numbers, you get 52. You can check at the end of the lecture. Minus, this will be this 4 times this one is 8. So the result will be, it is, this one is 260 minus 32. The final answer will be, it is 228. Now, let's continue to the third example. Okay, this one. The summation of 2k squared, k starts from 1 up to 4. So let me give you for this 40 seconds. Let's try this question. We'll do it together. Time 30 is this 60. So this is the final answer. The fourth example, the summation of this, the logarithm of n plus 1 over n the base 3, where n starts from 1 up to n6. So to find this sum, let's do it together. Let's do together this question. First, when you put 1 here, you have 2 over 1. Logarithm of 2 over 1, the base 3. Plus, when you put 2 here, it is the logarithm of 3 over 2 in base 3. Plus, when you put 2, 3 plus 1, it is 4. 4 over 3. The logarithm of 4 over 3 to the base 3. Plus, it goes on like this. So, when you put 25 here, the logarithm of 26 over 25. And finally, when you put 26, you have this one. 26 plus 1 is 27 over 26. So the logarithm of 27 over 26 to the base 3. So we need to add these numbers. So to add these numbers, you have to remember the properties of logarithm. So using that, you can evaluate this. The logarithm of 2 over 1 to the base 3 means division can be converted into subtraction. So this is logarithm of 2 to the base 3 minus logarithm of 1 to the base 3, this one, plus this will be the logarithm of 3 minus the logarithm of 2 in base 3, plus it goes on like this up to the last term, this one, the logarithm of 27 in the base 3 minus the logarithm of 26 in base 3. So when you add this, look, when you add this, this term, logarithm of 2 to the base 3, cancel with this one, the opposite. And logarithm of this term, the logarithm of 3 to the base 3, is cancelled by this term, the opposite. If you just continue like this, look this one, this term, the logarithm of 26 in base 3 is cancelled by the logarithm of 26 in base 3. So this term will be cancelled, the term ahead of it, and here this also will be cancelled. We'll have this one, logarithm of 4 to the base 3. On the next term, we have the logarithm of 5 in base 3 minus the logarithm of 4 in base 3. So this will be cancelled here. So the remaining terms will be this one, the last term, this. We don't have a term that cancels this logarithm of 27 in base 3, and we don't have the term that cancels this one also. So the remaining terms are these two. So this means the answer will be the logarithm of 27 in base 3 minus the logarithm 1 in base 3. So this will be the answer. So this one, it is logarithm of 1 in base 3. It is 0 logarithm of 1 in base 3. This will be logarithm of 3 to the power of 3 in base 3. This one. So 3 to the power of 3. This will be the logarithm of 3 to the power of 3 in base 3. So using logarithm property, you can take this 3 in front of log. So this 3, the logarithm of 3 in base 3. Logarithm of 3 in base 3 is 1. So the answer will be 3 times 1 is 3. So the final answer will be 3. So this is it. Now let's see one more additional example for this property of summation notation. Now let's see this one. Look this. Let the summation of a k where k starts from 9 up to 20 is given. It is 40. And the summation of -5 plus 4 ak, k starts from 1 up to 20 is given to be 200. Then you are asked to evaluate this one. What is the value of the summation of ak where k starts from 1 up to 8? So to solve this, we need the property of summation notation. So let's see this one. Look, to solve this problem, we have summation from k up to 20, summation from k 9 up to 20. So we are asked to find summation of ak 1 up to 8. So the property I must use to solve this problem is in this form. The summation of ak, k starts from 1 up to 20. This is equal to the summation of ak, k starts from 1 up to 8. We need this 1 up to 8 plus the summation of AK, K starts from 9, next term 1 up to 8, the next term is 9th term, 9 up to 20. So we know this property. Using this property, I can find this one. We are asked to find what? This, the summation of AK. K starts from 1 up to 8. Here, we have this one, the summation of, summation of AK. K star from 9 up to 20 is given. The summation of AK, K star from 9 up to 20, this is known. This is known. And we need to find this one. But this is not known. The summation of AKK starts from 1 up to 20. But here, the summation of -5 plus 4 AKK starts from 1 up to 20 is given. So from this, I can find the summation of AK. So let's start from this one. After finding summation of AK, K star from 1, we will have this result. So after that, we know these two, so I can calculate this. So let's proceed from this part. Let's try to find first the summation of AK, K star from 1 up to 20. So the summation of -5 plus 4 AK, where K star from 1 up to 20 is given. It is 200. From this, we'll try to find this. So to solve this one, this implies, using the property of summation, this can be distributed over the 2. So the summation of -5, where K star from 1 up to 20, plus the summation of 4AK, where K star from 1 up to 20 is equal to 200. So from this, we know this property is a constant. So the sum of this means we have take the difference of 2, 20 minus 1, 19 plus 1, 20. We have 20 -5s. So this will be this -100. So, or -5 times 20 plus, you can take 4 outside from the summation, 4 times the summation of AK, where K star from 1 up to 20, this is equal to 200. So from this, the summation of this result, the summation of 4 times AK, where K star from 1 up to 20, this is equal to, we have 200 here, this is -100, so put the other side, and the result will be 300. So the summation of, to find this summation of AK, divide both sides by 4, you get this result. When you divide by 4, the summation of AK, K star from 1 up to 20 is equal to 300. Divided by 4, it is 75. Now, so we have this one. We have summation of AK, K star from 9 up to 20. We have the summation of AK, K star from 1 up to 20. So we can find easily summation of AK, where K start from 1 up to 8. So the summation of this AK, K star from 1 up to 20 means the summation of K, K star from 1 up to 8, plus the summation of AK, K star from 9 up to 20. So this implies, we know this one, or we have found this to be 75. This is equal to the summation of AK, K star from 1 up to 8 is not known. We need to find it. So summation of AK, K star from 1 up to 8, plus the summation of AK, K star from 9 up to 20 is given. It is 40. This is plus 40. So from this, the summation of AK, K starts from 1 up to 8. This is equal to, take 40 to this side. You will have 75 minus 40. So the 75 minus 40 is equal to 35. So this will be the final answer. So this is all about today.